Okay, so now that we've gone through examples 1 and 2 on 2.6, let's look at some of the problems that you need to do. So I believe your assignment is 5 through 50, the multiples of 5. I'm going to look at some, though, that are not included in those. So how about we look at number 9? So number 9, it tells us to find the domain of each function. And it says f of x equals 1 over x plus 7 minus, it's a plus, 3 over x minus 9. All right, so when we're looking for the domain, remember, look for those restrictions. And we have 2 of them. They're both fractions. And so with a fraction, remember, we know that the denominator cannot equal 0. So we know that x plus 7 cannot equal 0. And x minus 9 cannot equal 0. And so we're going to solve both of these. And so we see that x cannot equal negative 7. And x cannot equal positive 9. So remember, we've done this before last semester. So if nothing else, let's draw a number line. It doesn't say we have to, but it helps us see our intervals. And so let's put those two, put your inequalities on there. And then put your numbers there. So negative 7 and positive 9. And we said x cannot equal them. So remember, we're going to use open circles there. Well, if x cannot equal those two numbers, that means x can equal everything else. So I'm going to shade this here. All right, so we've got 3 intervals here. And so this first interval starts at negative infinity and it goes to negative 7. And we're going to use a parenthesis there because remember, it's an open circle, which means it's not equal to. Union, and then we're going to start again at negative 7 with a parenthesis because it's not equal to. And we're going to go to 9. Again, it's an open circle. It's not equal to, so you use a parenthesis. Union, and then that last part there is going to start at 9, not included, and it's going to go to positive infinity. So this would be our domain for number 9. Okay, so let's also look at number 16. So number 16 says f of x equals 1 over 4 over x minus 2, and then a big minus 3 there. All right, so, well, we know our denominator cannot equal 0, but that's going to get messy. So why don't we simplify this first? So remember, this right here is our problem. If we didn't have that little fraction right there, we wouldn't have an issue with it. So how do we get rid of that little denominator there? Well, we multiply by it. And what we do to 1, we have to do to all. So all of this is going to get multiplied by x minus 2 every term. So when we do that, we get f of x equals, on top we have 1 times x minus 2, so let's distribute the 1. So we get x minus 2 over, on bottom here, this first group, the x minus 2's cancel, so we just get that 4. And then here we're going to take that negative 3 and we're going to distribute it. So minus 3x plus 6. And we can simplify that as x minus 2 over, I have, what's that, negative 3x, and then we got like terms, 4 plus 6 is 10. All right, and from there, now we have a fraction. We know our denominator cannot equal 0. So negative 3x plus 10 cannot equal 0. We're going to solve that. I'm going to move the 3x over because it's negative, and I know y'all don't like negatives. And so we got 10 cannot equal 3x. Divide by 3, and so we get x cannot equal 10 over 3. So when I draw my number line, I'm going to put my negative infinity and my positive infinity. Some of y'all know what 10/3 is approximately. Some of y'all don't. That's okay because it's the only number we've got. If we need an approximation, we could put it in a calculator and find it is 3.666666666. No, I'm just kidding. It's 3.3333333, and it just keeps going. But we don't have to know that because it's the only number there. All we have to know is it can't equal it. So if it can't equal 10/3, that means it can equal everything else. And so I can see here on my number line that I have two different intervals. I have this one here and this one here. So it's going to go from -infinity to 10/3 with a parenthesis because it's not included. And then we're going to start again at 10/3, not included, and go to +infinity. And so there's our domain for this one. All right, let's look at a couple more. So what about number 20? How about 19? So we're still looking for the domain, and it says that f of x equals 1 over the square root of x minus 3. All right, so we have a fraction, so we know our denominator cannot equal 0, but we also have a radical down there, which means it has to be greater than or equal to 0. So think about it like this. Denominator cannot equal 0. Well, let me do it with the actual part. So the square root of x minus 3 cannot equal 0, but the square root of x minus 3 has to be greater than or equal to 0. We'll put them together. So that means that the square root of x minus 3 can only be greater than 0. And so let's go ahead and square it to get rid of that square root. So that means that x minus 3 is greater than 0. Add the 3. And so we get x is greater than 3. So if I put this on a number line, I've got 3. It's not equal to. And we know x is going to be greater than. So we're going to pick numbers greater than. And I forgot to put my infinities, which I know better. All right, so now I can see my interval right there. So it's going to start at 3 with a parenthesis because it's not equal to, and it's going to go to infinity. And so there's the domain for number 19. So what about, let's see, number 26. So I'm going to clear this. So if you still need it, y'all need to pause it. All right, so number 26. Still looking for domain, and it says, it actually says h of x, not f of x. Doesn't matter, it's just a label for it, but I'll change it. So we have the square root of x minus 3 plus the square root of x plus 4. All right, well, we've got two radicals here, and so we know that both of these have to be greater than or equal to 0. Now remember, x has to be able to make both of these true. So first, let's go ahead and solve each one of them. So I'm going to square the first one here. And so we know x minus 3 is greater than or equal to 0. Add the 3. And so x is greater than or equal to 3. And the second one, we're going to do the same thing there. Let's square both sides to get rid of the square root. And so we got x plus 4 is greater than or equal to 0. Subtract the 4, and x is greater than or equal to -4. Now, when we put these both on a number line, I'm going to stack them. I'm going to put one over the other. So I need to put the 3 on here. I need the -4, and I need both of my infinities. Now, so this first one, I'm going to graph in red. It says x is greater than or equal to 3. So we know we're going to include the 3, and we're going to go to positive infinity. The second one I'm going to do in green. And so we know we'd include the -4, and we would go to positive infinity. Now remember, x has to make both of them true. So it's where they're both going to be graphed at. So I can see right here when I graph it, this is where they overlap. So they're overlapping right there, which is from 3 to positive infinity. Now is the 3 going to have a parenthesis or a bracket? Well, it's included in both of them because it's bracket on the top and it's colored in on the second part there. So you're going to put a bracket there. And so there's the domain for that one. All right, what about, I don't know, how about 27? '27 says g of x equals We have the square root of x minus 2 over x minus 5. Well, we have two issues going on here. One, we have a fraction, so we know x minus 5 cannot equal 0. And we have a square root, so we know the square root of x minus 2 has to be greater than or equal to 0. So we're going to solve them both. So we find that x cannot equal 5. Solve this one just like we did the previous problem, square both sides. And so we know x minus 2 is greater than or equal to 0. Add the 2. And so x has to be greater than or equal to 2. So let's graph this now on a number line. So I'll put my infinities. I've got a 2 and a 5. Now I know it can't equal 5, so I'm going to go ahead and put that as an open circle. And it says x has to be greater than or equal to 2. So it's equal to the 2, and it's going to be greater than, but wait, it can't be 5, so jump over it. And so now I can see my two intervals right here. So I can see that it goes from 2 up to 5, not included, and then from 5, not included, up to infinity. Okay, and then how about 29? Because I'm worried about y'all factoring the 4 terms, because that's where y'all seem to struggle some on factoring. So let's look at 29 together. So I'm about to clear this, so if you still need it, pause it. Alright, so 29 says f of x equals, has 2x plus 7 on top, over all that good stuff. So what is that? X cubed minus 5x squared minus 4x plus 20. Alright, so we know it's a fraction. So that x cubed minus 5x squared minus 4x plus 20 cannot equal 0. And so I know anytime I have more than one form of the x, so like x cubed and x squared, and then I even have an x, means I'm going to have to factor. So remember, in order to factor, you have it set equal to 0. And do they have a greatest common factor? Is x cubed, 5x squared, 4x, and 20 all 4 terms divisible by some number? It's not. So this is where we do our grouping. So we split it in half, and we're going to greatest common factor this side. What does x cubed and 5x squared have in common? Well, they both have an x squared. So write it down and then open a parenthesis, because remember, factoring means we're taking it out. So we're going to divide it out. X cubed divided by x squared gives us x. Negative 5x squared divided by x squared gives us a negative 5. And then we're always going to common factor out that sign. And then we got 4x and 20. What do they both have in common? Well, 4 and 20 are both divisible by 4, so let's take a 4 out. So really, we're taking a negative 4 out. So divide both of these by negative 4. So negative 4x divided by negative 4 is x. Positive 20 divided by negative 4 is negative 5. Close it, and I'm going to bring down my not equal to 0. And then remember, we're going to common factor one more time. So what does x squared times x minus 5 and negative 4 times x minus 5 have in common? Well, they both have an x minus 5, so put it in parentheses. We're going to divide by it, which is going to make both of those cancel. So what are we left with? On the first term, we have x squared, and the second term, we have minus 4. Cannot equal 0. All right, so that was factoring 4 terms by grouping. But then you got to look at this and say, are you done factoring? And we're not. This right here is a difference of squares. All right, so let's bring down that x minus 5 times. Remember, difference of squares. We're going to find the square root of each one. So what's the square root of x squared? And what's the square root of 4? And so then we write it as x plus 2 times x minus 2. And then bring down your cannot equal 0. And then check, can you factor anything else out? You cannot. So we're going to set each of those factors individually not equal to 0. So x minus 5 cannot equal 0. X plus 2 cannot equal 0. And x minus 2 cannot equal 0. So we're going to move the 5 over. And so x cannot equal 5. Subtract the 2. So x cannot equal negative 2. And add the 2. So x cannot equal positive 2. Alright, so I'm going to draw myself a number line over here. Put my infinities. I need negative 2, positive 2, and 5. And we said x cannot equal them, so they're all going to be open circles. And then remember, x can't equal them, but it will equal everything else. And so we can see that here we have 4 intervals. So my first interval is right there from negative infinity to negative 2. And then we have from negative 2 to 2. And we got 2 to 5. And then we got 5 to infinity. And so there is our domain for this problem. Okay, so I think I've covered one of each type so that you have something to look at to guide you to do the homework problem that is similar to it. Hopefully this helps. If you have any questions, just make sure you ask Miss Spates because she will be able to help you.